Hello everyone, and welcome to another video tutorial for Light-O-Rama S5. In today's video, we'll talk about creating pixel props in your preview that start in the middle of a string or need null pixels, either between props or at the start or end of a strand. The key to properly labeling your pixel props is remembering that each pixel on a strand has 3 channels per light bulb for the red, green, and blue channels, which is where we get RGB. Each strand of pixels gets connected to a port of a controller and assigned either a unit ID or a DMX universe. A pixel string itself does not get connected to a channel like when using an AC controller, and it is very important to remember that vocabulary difference for these types of scenarios in particular. First, we'll simulate drawing a roofline with one strand of 100 pixels coming from a singular controller port. You could choose to use the draw string tool all the way around, but you might not end up turning the corners on the correct bulb. So here's another option showing how to create exact sections of the roof outline one at a time. To start, I'll draw the first section of roof with the draw string tool. In my display, this section is going to have 30 pixels, which means in the prop definition window, I need to set the light type to RGB, the exact number of RGB nodes to 30, and leave the start circuit at 1 since this is the beginning of my strand. Since each of the 30 pixels takes up 3 channels, or circuits, the end circuit number is 90. This port happens to be assigned to unit ID 04 in my display, which I'll reflect in the prop name. The next segment would be the right side of the roof, continuing from where we left off in the strand. We'll follow the same process of selecting RGB as the light type, choosing 30 pixels for this string, and setting the unit ID to 04 because of my display layout. The difference is the start circuit. Since this roofline piece starts on the 31st bulb in the strand, we need to set the start circuit to 91 because each bulb needs 3 channels. This puts my end circuit at 180 since I've now accounted for 60 bulbs of this strand, 30 for each roof section so far. Lastly, I'll draw the bottom piece of the roofline, which is physically longer and needs 40 pixels, which puts us at 100 pixels in total. This time, the setting will be RGB, 40 lights, unit ID 04, and since the starting bulb is 61, the starting circuit needs to be 181. Looking at the end circuit lets me double check my math with all 3 segments. The fact that this end circuit number says 300 means that there should be exactly 100 pixels in the string going around the 3 sections of roofline, which is correct. The other difference with this segment is that the starting pixel is on the right, not the default left, because I'm outlining the roof continuing in a triangle instead of having each section start from the left. Once these 3 separate roof sections are drawn, I can create a group that allows me to apply motion effects as if they were all one section, or still work with them as isolated segments once I create a new sequence. Another example would be adding a star on top of a pixel megatree. This tree is set up with 50 pixels per strand, each attached to their own port of a Pixie 16. Because Light-O-Rama unit IDs use hexadecimal numbering, the unit ID of the last string is 2F, and I can see that the end circuit is 150 because there are 50 bulbs in this string. This is where I'm going to connect another strand of pixels and add the star onto that last strand of pixels so it becomes a set of 100. I'm going to select the nested star shape for the topper, choose RGB, then indicate that my outer star has 30 pixels and the second has 20 for a total of 50 pixels. Right now, each section of the star is set up to be on a different unit ID, but by unchecking this box, I can set it all to be one continuous strand and therefore unit ID. Since 2F was the string unit ID for our 16th port on the Pixie, I'll set the unit ID to 2F and the starting circuit to 151 since this star will start on the 51st bulb connected to that 16th port. The last example is for null pixels, or pixels that physically exist in your strand but you skip over an assignment so that they don't light up. We'll use the arches as an example. Right now they're set to 50 pixels each, but let's pretend I wanted to use one strand of 100 pixels per 2 arches instead of 4 strands of 50 at one port each, but couldn't quite continue right on to the next arch because of how close the pixels were spaced. In this example, each arch will need to have 48 pixels instead, and there will be a 4 pixel gap between the arches that won't light up at all when I go to sequence so that the arches can be physically placed 2 feet apart. The first arch is easy. I just have to change the nodes per section to 48. In order to get to the second arch, the bulbs 49, 50, 51, and 52 are going to be on the ground, giving me that extra 2 feet to reach the second arch, which means that I need to start arch 2 on bulb 53 of this strand. If we multiply 52 bulbs by 3 channels, that gives us 156, which means this second arch needs a start circuit of 157 and 48 nodes per section. Because those middle bulbs have no assignment anywhere in my preview, they won't physically light in the display, no matter what effects I apply to either arch. You can use this concept to skip bulbs at the start of your strand, middle, or at the end. Just do some quick math to figure out your circuits, remembering the rule of 3 channels or circuits per pixel. And that's all for this tutorial. Don't forget to like and subscribe so that you never miss a notification about new videos.